Good afternoon. This is my final project of graphs of polar functions. And I created this on the teacher Desmos page. And I'm going to go in with the student preview so that you can see what I would like for a student to do. All right, so the first page just gives them an explanation of what a polar graph is. It says you have used rectangular graphs up to this point. So what is a polar graph? A polar graph is a shape constructed using the polar coordinate system. Polar curves are defined by a point that are variable distance from the origin, the pole, depending on the angle measured off the positive x-axis. So in your rectangular graphs, you're used to the x and y coordinate, but in a polar graph, you have the r and theta, where r is your radius, and theta is the angle measured counterclockwise on the x-axis. All right, so the first screen that I show them is a circular polar function, and it's just simply from the equation r equals 3. And so I would want them to, how does this relate to what is shown in the graph? The r equals 3, that is, and then what is the rectangular equation for this graph? So I would want them to go through and see that the radius is 3 here, and that in order to write an equation, it would have to have center 0, 0, and a radius of square root of 3. All right, next page. Next, I show them a graph using cosine theta and 4 cosine theta so that they can see the differences between the two, where cosine theta just has a radius of 1, 4 cosine theta has a radius of 4, and I want them to see that it is a horizontal. Well, I guess you couldn't say horizontal, but it's going to be on the right and on the left sides. On the next screen, I show them the sine function with a radius of 1 and a radius of 5, and as you can see, that's a vertical circle. It would be along the y-axis. And so I also would want them to write the rectangular equation to the two polar graphs that are shown. So, having learned from those screens, what is this polar function? And I would hope that they would count it out and note that because it was in the center, it would be an r equals as opposed to an r cosine or an r sine equation. So what is this polar equation? Here we have a sine polar equation, and then this one would be a cosine polar equation. I expect them to be able to write what those are. So on the next screen, I show them just a point on the graph and to play around with A and watch what happens to the point. So it's going in a circular fashion, but then it's changing. And note what's happening with as A becomes a different number. So next we're going to look at S. Let's go back to A. Get back on the screen. What happened to A? But I want them to play around with the graphs. There we go. So that they can see what's actually happening here. And there it is. Stop. So I want this A, yeah, right in there, so they can see what's happening here, and then they can see what's happening there. I hate that it's going away, but I'm going to change that. All right, so the next screen is how would you graph 2 comma 2 pi over 3 on a polar graph, and then I have some ideas for them, and then there's a right answer and a wrong answer. 3 wrong answers. And then I want them to plot a point on the graph, just basically from what they just saw. Then we go into these popular polar graphs, the cardioid, the heart-shaped graph, and if you have 2 plus 2 cosine theta and 3 plus 3 cosine theta, these are our graphs. So what would happen if I had a 5 plus 5? Hopefully they would be able to figure out what would happen there. Then next, notice these are different. I have a 2 plus 4 as opposed to a 2 plus 2 and a 3 plus 5. What's different is that there's a loop in the center, what makes them different. And hopefully the students will be able to see that and determine what the difference is on what's causing it to have a loop. Then create a courtyard with a loop in the center, and I want to see if they actually understood. Then next we have our rose petals. The graphs you see are 5 sine 2 theta, and then the 5 sine 3 theta. So the 3 theta, hopefully they'll notice that it has 3 petals, and that it goes out to 5, a radius of 5. 3 petals, and then the 5 sine 2 petal might throw them because there's 2 on the top and 2 on the bottom, and they may think that it should be 4 theta. Alright, so this time I want them to create their own. I want them to change it to a polar graph, so I'm going to leave it as a rectangular graph. And then I want them to create their own rose petal. Then I created one myself, so just in case they didn't catch what was happening with the rose petal, then they can play around with this. We have, if there's not an 8 in sight, in case they thought this was 8 theta. So hopefully they will see how this function was created. And then we go into what is going on with this. How in the world could we create a function like this? So I want them to play around with the graph to see how they can create a petal that looks like this. Why is it diagonal? Why are there only 2? What's happening here? And hopefully they can figure it out as they work in groups. And then we have this one. A lot of petals, and not quite sure what's happening, but hopefully my students will look at that and be curious enough to try to figure out how this graph is created. And then next says name this function. Play around with Desmos and see if you can find a function that creates this graph. It's interesting. And we've seen those little spinners that looks like this, so hopefully we get a lot of conversation out of this. And then we start to multiply the functions. I told them I created this graph by multiplying sine theta and cosine theta, trying to determine the function of the graph. What sine theta, what cosine theta, and let's see if I can figure it out. And then lastly, I said write the function of the graph. You will have to combine 2 reciprocal functions. So we'll just see. You know, it's fine. Hopefully the students will have a lot of conversation about it. Hopefully this will cause them to want to play around with polar graphs and try to come up with graphs of their own. But all in all, I hope that this would be a fun and entertaining lesson for them. And then lastly, I asked them to write 3 things that they've learned about a polar graph. So hopefully we get what we need to get from this, which is learning how to plot points, learning how to plot a graph, cosine graph, a sine graph, a cardioid, a rose petal, a monocon. And then just creating fun functions. And that is the end of my lesson.